Hi, this is SYNTRX from Erica Synths, inspired by the interface of the legendary EMS Synthi AKS, a synth designed to keep all the benefits of modular synths without the hassle of patch cables. SYNTRX, however, has one major difference, and that's a digitally controlled patch matrix with presets. This enables it to make standard synth-like sounds, like what you're hearing now, but also other patches based on feedback and internal routing, oscillators feeding back into filters, into the reverb, and back into the filter, to create patches kind of like this one. There are a few things in SYNTRX that give it a special character. In this video, I'll review those things, go over quite a few patch ideas, which you may find useful in your sound design regardless of the synth you use. Let's get started. Before the overview, let's jump right into the matrix. SYNTRX is a totally modular synth, meaning it won't make any sounds until you make at least one matrix connection. Let me just choose an empty preset. Let's pick this one. Imagine all the boxes you see on the panel are individual modules, except that their inputs and outputs are on the matrix rather than on jacks somewhere on the panel. Sources are written on the left and destinations on the top. You move around the grid Etch-a-Sketch style with the two matrix click encoders and make connections by pressing the encoders. So for example, if I wanted to connect oscillator 1 to the output of channel 1, I would just find the spot and click either encoder. I click this encoder to make a full 100% connection and turn it off, and the left encoder has 3 degrees of connections: 100%, 70%, which isn't as bright, 30%, which is dimmer, and then off. Generally speaking, the top and left outputs and inputs are signal or audio inputs and outputs, and then the bottom and the right inputs and outputs are control voltage. That said, there's nothing preventing you from mixing those up, especially connecting audio sources into control inputs where a lot of the craziness here happens. To give you an idea of how this works, let's build a classic synth style patch where an oscillator is fed into a filter, then into a VCA, potentially into effect, a reverb, and then out into your speakers. There are 3 oscillators here. Let's just connect oscillator 1 into the input of the filter. Then we'll send the output of the filter into our VCA, into our envelope. All right, so we connect filter to envelope. Then I want the envelope signal to be fed into the reverb. So let's find that slot right over here. And finally, let's connect the output of the reverb into, say, in this case, channel 1. Now each of the channels can be panned separately. I'll just pan this dead center, open up the filter, turn down the resonance. I've got at least one of the oscillators of oscillator 1 turned up, in this case the sawtooth. And if all goes well, we should hear our sawtooth. We could then go ahead and filter it and turn up the reverb mix to hear the reverb, add resonance. So that's our basic synth patch. So what we have here are basically 4 cables. Each dot here represents a cable. Like I mentioned, oscillator into the filter, filter into the VCA envelope, envelope into the reverb, reverb to the output. This sort of roundabout circular motion is how you patch things in SYNTRX. So those are only 4 patching options, or 4 virtual patch cables out of 256 different options on this matrix. Now there are 2 things that make this workflow substantially different than regular modular synths. The first is that you can connect a single output to up to 16 inputs at a time with a simple click of a button, something that with regular modular synths would require 16 buffered mults. And the second is that you can connect up to 16 outputs into a single input, something that again in modular synths would require 16 different mixers with 16 inputs. A significant convenience in SYNTRX is that you can save these routings. So I can go ahead and save this routing in any one of the empty slots, any one of the unlit slots. Let's just say pick this one. This is now saved. I can then go ahead and recall any other slot. Let's bring this one up, for example. And then if I want to go back to the routing I just created, just go in here, loaded up. It should be noted, however, that while you can save these virtual patch cables, the presets don't also save knob or switch positions, so you don't get full recall of the entire state of the synth, which obviously matters a lot towards getting back the sound you created. So that's an overview of the patch matrix. Obviously, we'll be returning to this, but before that, let's zoom out and look at the synth overall. SYNTRX has 3 multi-shape oscillators with an LFO mode for the third oscillator. It also has a noise generator with color control, a sample and hold circuit which can either generate random or stepped values based on the third oscillator or the noise generator. In the middle is a low-pass filter module with self-oscillating resonance, and the patch matrix, of course, which even though it's digitally controlled, has a fully analog signal path. Off to the right is the ring modulation module, a spring reverb module with an actual spring inside the case, the Trapezoid, which is a fancy name for an attack sustain decay or an attack decay envelope that can also loop with controllable hold and off lengths, and finally a joystick, which has the added benefit of attenuators to let you control its ranges with precision. Up top are 2 speakers with separate on-off switches for each one, a control voltage or audio meter, also with a switch, level and pan controls for each of the 2 channels, so you could pan channel 1 to the left and channel 2 to the right, or just set them to the middle or anything in between and use the channels separately for different things. There's a tilt, low pass and high pass filter or boost or EQ, depending on how you look at it, for each of the channels. And then there are 2 audio inputs in the back with control over level for each of the inputs and a choice between mic and line level gain. The overall build of SYNTRX is very solid with a nice thick metal frame and wooden cheeks. Let's take a look at the back for connectivity options. SYNTRX is powered using a 12-volt external wall wart adapter. It has 1/4-inch headphone outputs as well as 2 individual channel outputs, like I said, left or right or for any other purpose. And it has 2 mono 1/4-inch audio inputs in the back, which, like I mentioned before, are fed into here with independent level control and mic and line settings for both. These 2 inputs are fed into the matrix and are available as outputs over here, inputs 1 and 2. They're AC coupled, not DC coupled, meaning that they can detect very fast voltage changes, or audio of course, but not static control voltage or slow moving LFOs. SYNTRX has MIDI in and through, and it also has 2 CV inputs and a single gate input. The CV inputs don't appear in the mod matrix and lead only to oscillators 1 and 2, letting you play them together if you send a single CV into CV input 1, or play them separately paraphonically if you send a different input into CV input 2, in which case oscillator 3 will follow oscillator 2. I'll give you an example of playing this paraphonically later on. SYNTRX also accepts pitch bend and mod wheel commands, as well as 2 additional CCs that can be sent to the joystick, and you can assign velocity to the filter as well. To complete the overview, note a module that most synths have and SYNTRX doesn't, and that's a mixer. I mean, technically it does, and that's the matrix, but it only gives you 3 degrees of level control, like I mentioned earlier, rather than spread 16 tiny knobs on each and every one of the outputs over here. Each module has dedicated level knobs that let you control the level of the audio or modulation going into the patch matrix. All right, before we go into the patch ideas, let's take a deep dive into each of the modules and take a close listen to them. I'll start with the oscillators. For this, I'll patch the oscillators directly into the outputs because when you pass them through the filter, at least in this prototype, the filter does chop off a little bit of the high end. So I'll just open up an empty preset. Let's pan the channels left and right and connect all the oscillators to all the channels. Let's take a listen and look at the oscillators. There's a sawtooth, which sounds deep and nice, I think, and has a very broad range. And then a variable shape sine wave, sort of morphs its shape as you change its frequencies, and has a variable wave shape from sort of like a saw to this shape, and let's increase gain, see what happens to it. So that's oscillator 1. Oscillator 1 also has an octave control switch, octave up and octave down. Oscillator 2 is a variable shaped triangle and square. Let's take a listen to it. You control the variable shape of both of the shapes using this knob. So this is the, like I said, sort of triangle to saw. And the square. With pulse width control. There's no pulse width modulation, by the way, unfortunately. There's no input here for any of the shaping knobs, actually. And the switch here controls oscillator sync. This works better with this shape, in which case oscillator 2 is reset by oscillator 1, making the familiar oscillator sync sound. For oscillator sync to work well, you need the frequency of oscillator 2, in this case, the slave, to be higher than the frequency of oscillator 1, the master, in this case. So that sounds nice. Then there's oscillator 3, which is similar to oscillator 2, except that its special power is that it can also be free running as an LFO, as a low frequency oscillator, rather than oscillator sync. So if I flip the switch here, it'll go to extremely low rates, all the way to 0.05 hertz compared to 1 hertz on the low end on these oscillators, and up to 500 hertz in LFO mode. But like I mentioned, in key follow mode, it'll just follow the keyboard like the other oscillators. Aside from the oscillators, SYNTRX also has a noise generator, which, dare I say, sounds quite nice and goes from a low pass filter rumble all the way to high pass on the noise. And then SYNTRX also has a sample and hold module. Sample and hold will take any waveform coming into it and freeze it at a rate determined by the rate knob. The incoming waveform can either be VCO3 or the noise. The sample and hold circuit shares an output with the triangle waveform of oscillator 3. So you can choose to send out either oscillator 3 using this switch, just the sample and hold circuit, and that's the clicking you hear here, or a combination of sample and hold and the output of oscillator 3. You can also determine what input or what waveform goes into the sample and hold circuit. It can be either VCO3 or the noise coming out of the noise generator. Long story short, the effect is, if we say connect the triangle waveform out to, let's say, the frequency of oscillator 1, let's listen to that. The result is either a modulation, which is a clean pass-through of oscillator 3, a sample and hold of the input of oscillator 3, which causes a staircase at the rate of the rate. I know this sounds random, but it's following oscillator 3. So these aren't random numbers, but if we change the input from oscillator 3 to the noise generator, then you'll get completely random values. And you can also combine VCO3 and the sample and hold output to this sort of crazy random and not random shape, which is obviously changes based on the rate of the sample and hold circuit and oscillator 3. So yeah, definitely a nice source of craziness and uncertainty in the sample and hold circuit. Let's move on to the filter. I'll just feed it a clean oscillator 1 into the filter, and then filter, let's connect it to both outputs. So the filter without resonance sounds like this. You can hear that it's quite different than your typical low-pass 24 dB per octave filter. This is a diode-based filter as opposed to a transistor ladder filter. And with resonance, which is an emphasis at the cutoff frequency, you can start to hear the harmonics. Now, the resonance will self-oscillate, but only if you don't feed it audio at too high of a level. So you can hear its character change here. If I reduce the level of the oscillator coming into the filter, you can start to hear it. Very raspy. If I lower this down all the way, it will, like I mentioned, self-oscillate and create a sine wave. That's what's called a filter oscillator. But like I mentioned, if you start feeding it audio at too high of a level, it seems like it'll sort of saturate at above this rate, this level. So you just need to be aware of that if you want to hear the raspiness and squelchiness of the filter, give it some room to breathe here. The filter, by the way, will reduce the bottom end a little bit when you increase resonance. Not by too much though, I think, compared to a ladder filter, to a transistor-based ladder filter, but it still does. Now, aside from the filter, each of the outputs has its own tilt filter as well. So if I disconnect the filter from the outputs and just hook up the oscillator again, say to input 1, and pan it straight through, let's take a listen to oscillator 1. Okay, this is our sawtooth. The filter, the output filter on the channel itself, is also a low-pass to high-pass filter. Seems like it also amplifies as well. Right? Increases the bass. So not just filter the high end, but also increase the bass here and increase the high end at the expense of the bass here. So nice tilt filtering here on both outputs as well. Now currently there's no keyboard tracking for the filter. I asked Erica Synths about that and they mentioned that's a feature or an option they might add in the future using either MIDI commands or the little MIDI button in the back. Let's continue our left to right tour to the ring mod circuit. Even though it's only one knob here, it gets 2 inputs on the panel and it's actually, I think, a lot of what makes the character of this synth special. Ring mod will take whatever's fed into column A here and multiply it or modulate it with the contents of whatever's fed into input B here. So let's take, for example, oscillator 1 and multiply it by oscillator 2. And let's bypass the filter and only use the output of the ring mod circuit, only send the output of the ring mod circuit to, say, channel 1, which is panned. So right now we're multiplying oscillator 1 by oscillator 2. It's not enough to bring up one of them, you need to bring up both, because multiplying something by 0 is 0, and that's ring mod, which can sound very atonal if there isn't an octave or half octave relationship between the oscillators. And I think it's that motion between a clean ratio between the oscillators and an uneven relationship or ratio makes ring mods special. More examples in a bit. Next up is the reverb. Let's take a listen to that. Disconnect the ring mod. Disconnect the ring mod here. Let's take oscillator 1 again into the reverb input, reverb output to channel 1 again. So when the mix is set to 0, we'll just hear our oscillator. And as we increase the mix, you can hear that spring reverb character. Now, there's an actual spring in here, so even if I shut this off, you can hear it ring out as I hit the synth or even my desk. So obviously the spring reverb is a major element in the character of this synth, and it will self-oscillate too. It's got feedback control. If we carefully bring this up, maybe give it a little nudge. Okay, so nice feedback there. The feedback will intensify if we turn on the speakers. Remember, the spring reverb is a physical spring inside the box. So this speaker is now on, and let's turn on the second one. And let's connect the reverb to channel 2 as well. Turn this on. Yeah, a lot of interesting artifacts here when the physical speaker is fed into the reverb. The reverb circuit is a little bit noisy. If I crank this up, you'll hear it. And you can either try and filter that or turn off the display, which still keeps the connections active, which substantially decreases the noise. The more lit elements, the more noise you get inside the reverb, so it's best to turn it off if you plan to listen to the reverb at high levels. Let's move on to the Trapezoid, which is a fancy name for an either attack decay envelope, an attack sustain release envelope, or a looping envelope with on and off controls. So an envelope that goes up, stays on, goes down, then stays off for a certain time and loops back. Let's take a listen to it. Disconnect oscillator 1 from the reverb, patch it in to the envelope. Now the Trapezoid has two outputs. It has a signal output, which is the VCA that the Trapezoid controls, and that's what we want to hear if we want to hear the audio being routed through the Trapezoid. And it also has a Trapezoid output, which is the control voltage sent out with which we can modulate other parameters like, say, the filter, for example. So let's just disconnect the reverb. So in attack decay mode, it'll go through an attack time, the on period, and a decay. So if I trigger the envelope with this button, you'll hear the slow ramp up, the on stage, and the decay, regardless of how long I press the attack button. Or of course a key on the keyboard, so if I hold the key, it'll still decay because we're in attack decay and not in attack sustain decay mode or attack sustain release mode. If we flip that on, the note will be held for as long as I hold the key, and then decay or release. And of course I can trigger it here as well. And then if I move the off knob out of manual into anything less than manual, 9 and below, the envelope will start to loop. Let's just maybe turn down the attack and decay. It'll loop based on the on and the off times. So a shorter on and longer off, or shorter off and longer on, or any combination of attack on, decay, and off. Fairly straightforward, looping envelope. This goes fast, but not into very high audio rates. If I sort of lower everything down, that's about as fast as it'll go. So that is the attack decay, attack sustain release, or looping envelope. Remember what I mentioned earlier, this sends out both a VCA signal, right? So that's the level of the sound, and a modulation depth with a Trapezoid mod depth. So this won't impact the sound, it'll impact whatever I do with the output over here. So let's say that I wanted to use the Trapezoid to modulate the filter. I would first need to disconnect the oscillator from the envelope, connect it to the filter, connect the filter to the envelope. So now we can hear the oscillator go through the filter. And if I wanted to modulate the filter cutoff with, whatever attack decay parameters I had here, I would hook the Trapezoid output, right, the control voltage coming out of the Trapezoid into the filter frequency. Then I could control its depth either with the Trapezoid depth, maybe make it like this. You can hear the filter open up. And close down. And this is the mod depth. And I could also control mod depth, remember, with the attenuation here. So up until now I've been using this either at 100% or 0, but I could use any of the steps here to get 100% or 70% or 30%. Let's move on. We've got the joystick here with X and Y controls and level or attenuation for the outputs of every axis. You've got 2 rows here for the outputs of the joystick. Let's say connect one of them to the filter frequency. That's the x-axis and the y-axis. Let's connect to the pitch of oscillator 1. That's this guy over here. So now we can open and close the filter with the x-axis motion and change the pitch of oscillator 1 with the y-axis. And if these motions are too extreme, we can attenuate them. That's basically what I did in the intro to this video. Set this to an octave range, set the x-axis to an octave range, which gives you nice control over crazy intervals, but have the safety of an octave up or an octave down at the extremes. Let's step right up into the meter. Like I said, it can meter either control voltage or audio. With control voltage, I can say monitor what's going on with either of the axes of the joystick. So notice as I move the joystick, we control the meter. And for audio, let's take the envelope signal, move this to audio. We can hear the level of the audio coming out of SYNTRX or any one of the other outputs we connect into the meter. Let's continue with the tour. The speakers are, of course, stereo based on the panning of each of the 2 channels, channels 1 and channel 2. You can turn them on and off individually. Now, in general, I think that speakers on synths are a waste of space and resources, but I have to say that these speakers are the exception to the rule, not because they sound as good as studio monitors, because they don't. They obviously can't push out bass like larger speakers, and if you push them really loud, they'll cause the case to resonate at certain frequencies. But that said, listening to them on their own, and certainly alongside studio monitors, substantially enhances the experience of using this synth. It sort of gives it a physical presence, especially if you program stereo patches. So these 2 alongside studio monitors, or even on their own, sort of fit the character of the synth quite well, I think. Okay, let's talk about the inputs. I'll turn these off so I don't get any feedback. I plugged a little microphone that I had around the house into one of the inputs. I'll swap this to mic, and let's connect input 1, which this is plugged into, to our filter as well. Let's try and maybe loop the envelope. Hello, hello, hello. Turn on some resonance. Hello, testing 1, 2, 3. And yeah, maybe decrease this. Hello, filter it, hello. So this is my voice with a nice filtered tremolo. And we can go crazy, pass it through the ring mod, why not? Say together with oscillator 1. And then instead of plugging channel 1 into the filter, let's take the ring mod and plug that into the filter. So let's ring mod my voice along with oscillator 1. Hello. How are you doing? What's up? So clearly more experimentation is needed here, but you can of course pass your voice, drums, synths through this, through the ring mod, through the reverb, through the filter, or in combination with anything you like here. So let's take a look at a few patch ideas and get to know the synth and the matrix a little bit better. So like I mentioned, this is a 3 oscillator synth. We can bring all the oscillators up, tune them relative to each other, of course. There's no pulse width modulation directly, but 2 squares will give you a PWM-like sound. Of course, you can tune intervals. That's quite a few harmonics too many, but yeah, we can tone this down. So transposing chords is quite easy. Let's switch setups very quickly. Let's take a look at a simple paraphonic or semi-polyphonic patch. I've got a bass drone controlled by the left side of the keyboard going through the filter, controlling oscillators 2 and 3 through CV. Oscillator 3 follows oscillator 2 if oscillator 2 receives CV in the back, and then oscillator 1 going through the trapezoid so it gets its own envelope, going through the reverb, then through the output in channel 1, which can be filtered here as well. And the end result is a patch that can be played polyphonically or paraphonically, depending on your definition of those terms. And of course we could then continue to mess things up, so maybe change up the timbre of the right side oscillator, oscillator 1, with FM. With this FM, obviously, results can be unexpected. Sometimes nice, sometimes need some work. Depending on the ratio between the modulating oscillator, in this case, oscillator 3, and the carrier, in this case, oscillator 1. Back to this setup, if we give up oscillator 3 as an oscillator and just use it as an LFO, we can modulate, say, the pitch of oscillators 1 and 2 to create nice, gentle vibrato. If we go ahead and, of course, connect oscillator 3 to the pitch of either 1 or both of them, increasing the speed of the LFO will take you from a gentle vibrato to wild FM at high frequencies, well into audio rates. But for gentle vibrato, turn the mod depth down and the rate. This works very nicely with oscillator sync as well. Let's disconnect this from oscillator 1. When you modulate the frequency of the slave oscillator, the oscillator that's being synced to oscillator 1, oscillator 2 in this case, it will change its character rather than its pitch. A quick change of setting, I brought in an MPC to create a multi-sample sample pack out of a few interesting sounds. I'll put this on my Patreon. This whale call-like sound is a result of ring mod from oscillators 1 and 2 being fed into the filter, along with oscillator 3 that's modulating oscillator 2, which is where that slow whale call in the background kicks in. There are also a couple of attempts at making this patch stereophonic by having oscillator 3 in very slow LFO mode modulate the level of output channel 1 and the trapezoid modulate the output of channel 2. Let's take a listen to a different sound that I think also has this metallic character that SYNTRX's ring mod brings to the table. This patch plays with the different intensities you can set up as virtual resistance pins on the grid. We've got 3 oscillators here. Filter opening up slightly, this one way up high, this one a 5th, but also ring modded together with this. The result is I think pretty deep ring modded sound. Now it wouldn't be a SYNTRX or Synthi style tutorial without an on the run patch. But what makes this patch special is the way that it's routed or wired up. Even though the inputs in the back of SYNTRX are AC coupled, meaning they can't accept control voltage, they do accept voltage bursts in the form of gates coming in from keystep in this case. And in this case, the gates are routed into the ring mod to create a different VCA style envelope for the hi-hats. So input channel 1, which is gate combined with the noise into ring mod, and then routed to output 2 means that we have effectively a separate hi-hat channel, which we can filter separately. Now what this means is that we have effective control over two different envelopes, one for the hi-hats and one for the main bass line. So if we just listen to the hi-hats, I can control their gate here with the key steps gate. Now because the input in the back is AC coupled, we don't have full control over the envelope, but still we do get a certain degree of control. So that's the hi-hat decay, and then for the main line, it gets its own VCA and envelope through the trapezoid. And this lets us control the contour of the bass completely separately from the contour of the hi-hats. Another fun thing you could try is using one of the outputs as a send for an external effect. So this does mean giving up a stereo SYNTRX, but the trick is to route one of the outputs to an external effect as a send, and then use one of the inputs as a return from that effect. So let's take this simple patch of an oscillator going through the filter, envelope, and reverb. Now I want this effect to happen before the reverb, so I'll disconnect the envelope signal from the reverb and send it out to output 2. Now we won't hear anything unless we connect channel 1, the input, into the reverb. So now, this is my dry signal, and KFM is a lovely pedal that brings in nice modulation into the sound. Let's bring in the reverb. Again, with and without the pedal in the signal chain. Okay, let's take a look at the pros and cons of SYNTRX. Overall, it wasn't designed to include all of the amenities you might find in modern mono synths. There's one envelope, one LFO. Rather, the idea here is to be inspired by the original EMS Synthi and think of a few modern touches that can be added to it, namely presets and the matrix, MIDI, and a few other upgrades here and there. Now, despite those little upgrades, this is still very much an analog beast. Getting it in tune and keeping it that way requires your attention. It doesn't just happen on its own. Also, even though the patch matrix is digitally controlled, it makes simple analog connections, either direct connections or attenuated at the 70% or 30% levels. You can't invert the signals, so there's no attenuverter in here, and you can't modulate the depth of a particular connection. A few more cons that may potentially be fixed in a firmware update. You can't currently play SYNTRX paraphonically via MIDI, only via CV, and you can't change patches with MIDI program change commands. Both would have been fun options. Like I mentioned, you can't currently track the filter to the notes you play on the keyboard, but I'm told that option may be coming. On the pro side, you get to enjoy everything that exists in modular synths here with presets for patch cable routings. There's a little trick I sometimes do in my videos where I snap my fingers and clear cables in a complex zero rack setting, and then a new patch immediately shows up. Here, that actually works without any editing tricks. You just hit recall and bring up another patch, hit recall again, bring up an old one. This matrix is a true game changer if you like to explore complex audio rate patches, because you don't need to throw away elaborate patches once you have them set up. Starting something new and then going back to continue working on an old complex patch literally takes an instant. It's nice to have the freedom to just patch anything to anything and see what happens. Aside from the matrix, what SYNTRX lacks in terms of a long laundry list of features, it more than makes up for in character. Its unique filter, the speakers, the spring reverb, the ring mod, and all the crazy patches that can be made by connecting everything through the matrix make this a unique and quite charming synth. The fact that you have full access to the left and right output channels also opens it up substantially in terms of creating stereo soundscapes. The biggest thing I can say against it is not the features that it lacks, but just its price. It's about $2,500 or euros. Unfortunately, that's not a synth that will be in the hands of many people, and that's a bit of a bummer because it's a unique, special, and different beast with patching and routing options that are quite unlike other synths. If you want access to the multi-samples I created in this video, as well as my ever-expanding book of electronic music ideas, tips, and tricks, check out the link to my Patreon below. Hit like if this was useful. Don't forget to ring the bell after subscribing to make sure you don't miss the next one. Thanks for watching.